Let's graph another polar equation. Here we're given r is equal to 1 plus 3 times the cosine of theta. I've drawn a t-chart over here, again working in degrees. I think that's best. When we're at 0 degrees, if we plug this in here, we have 1 plus 3 times the cosine of 0 degrees, which we know to be 1. So we'll have 1 plus 3, which is 4. So at 0 degrees, we have the point 4. All right, so 4 comma theta, remembering that our ordered pairs are all in the form r comma theta. All right, now let's plug in 45. 1 plus 3 times the cosine of 45, we're going to get an approximate answer here of about 3.12. So working on the 45-degree angle, we're going to go 1, 2, 3, and just a smidge outside of that for 3.12. Let's work our way over to 90 degrees. We're going to have 1 plus 3 times the cosine of 90 degrees. Cosine of 90 we know to be 0, so this will simply be 1, and we have that graph already right here. All right. Interesting thing happens between 90 and 120. I think it's right between those two values where we get the origin. But moving to 120 here quickly, we plug this in 1 plus 3 times the cosine of 120. We get a negative 1/2. Now careful here when we graph this. At 120 here, we need to go a negative 0.5. So that's down right about in this region here. Moving to 180, 1 plus 3 times the cosine of 180 is going to give us a value of negative 2. So when we're out here at 180, remember the negative flips this across the theta equal to pi halves axis, and we have our graph. Now, the great thing about this polar equation is that we have symmetry with respect to the polar axis. Remember, this occurs if we can replace theta with a negative theta, and it leaves our equation unchanged, then we have that symmetry through the polar axis. Using the fact that the cosine is an even function, we're good to go here, so we can plug in some other values here. 120 then relates to 240 degrees. So when we're looking at 240 degrees, we're at negative 0.5, so that's right in here, and you can see the symmetry across that axis. In a similar fashion, 90 relates to 270. When we're at 270, we have a value of 1 right there, and you can see the symmetry across that polar axis at this point. Continuing through, when we get to 45, that relates to 315 degrees. We can see that symmetry down this axis to this point right there. So this gives us a nice perspective on what we'd like to do for this particular problem. So now what we're going to do is put this all together and just go ahead and graph. Remember, we started with 4, 0, and as you graph this, it looks something like this. Take some doing and some practice to graph this, called a limacon. Comes around, and we tie this in, and there's our nice graph of the polar equation. R is equal to 1 plus 3 cosine theta.